Okay, so the second problem that we're going to do is we're going to figure out what happens when the side lengths of two similar polygons, when a side length has a fraction. So if there's ever an instance where there are fractions in the ratio, you have to get rid of those fractions. We do that when we multiply whatever we choose to multiply by. It depends on what the fractions are. Multiply the numerator and the denominator by the LCD, least common denominator. And then we reduce. Okay, so let's come down here. Now, one thing you'll notice about these two triangles, they didn't give us the third side. Well, but this is an isosceles triangle, so you know that this is 4 and this is 8/3. So we're not going to have to check all three this time since we know we've got an isosceles triangle. We just can do it twice, okay? And so let's, of course, write out the similarity statement. I think that'll help. So triangle ABC is similar to triangle LMN. Okay, I went in this order. Okay, so one pair of sides, these two here are actually already regular numbers. So let's go ahead and do the similarity ratio of those. And honestly, it doesn't matter which way you do it, if you want to do the bigger to the smaller or the smaller to the bigger. I just always am in the habit of making the ratios be from small to big. So I'm going to do the NM, and that corresponds to CB. NM is 10, CB is 15, and if you divide both of those by 5, the fraction reduces to 2/3. So the question is, do these reduce to 2/3? Well, those are a little bit more work. LN corresponds to AC, but LN is a fraction, 8/3, and then AC is 4. So before you can do anything on this one, we're going to have to get rid of this fraction. So since there's only one fraction, the 3 is going to be the least common denominator. So I'm going to multiply by 3, but I have to do that in the denominator even though the denominator does not have any fractions in it. Because whatever you do to the numerator, you have to do to the denominator. That's going to make the 3's cancel, and I'm going to end up with 8/12. From here, now I can simplify that. And if I divide both of those by 4, I'm going to get 2/3, which is the same ratio as this one. So these are congruent, these are similar triangles, and they have a similarity ratio of 2/3. Again, I don't have to try these sides because they're the same. So anytime that you're doing your homework, you may be asked to find whether or not they're similar, and you're going to have to test each side to make sure they're proportional and that they reduce to the same similarity ratio. If not, then you'll say not similar. If they are, then you'll give the ratio, which you will have already done because you will have tested them.